Okay, so in 4.3, let's take a look at some of your homework questions for 4.3 here. 4.3 was talking about the unit circle and the trig functions associated with the unit circle. So in question number 3, there's a few things that we have to remember about the cast rule. That's an important thing here. Let's read it. It says, if theta is an angle in standard position, so we know standard position, let me just fix that for you. So if theta is an angle in standard position, so remember standard position has the vertex at the origin. We have the initial arm of the angle is on the positive x-axis, and then standard position is going to go counterclockwise, okay? And of course this is quadrant 1 over here, quadrant 2, 3, and 4. Okay, should know that. It says this, with the following conditions, in which quadrants may theta terminate? So is this a quadrant 1, 2, 3, or 4 angle? So for A, if we look at A, cos is greater than 0. Cos is greater than 0. So you want to look at your cast rule, and the cast rule says we start in quadrant 4, C, and then A, S, T. This means that cosine is positive down here in the 4th quadrant. Cosine is also positive in the 1st quadrant. You see? Cos is positive, and all are positive. So, in which quadrants may they terminate? For this one here, it could be 4, or 1 or 4, I guess. 1 or 4. 1 or 4. Okay? Tangent is less than 0. Okay, well, tan is positive here, and so tan is actually negative in quadrant 2. It's negative in quadrant 2, and negative in quadrant 4, looks like, because only cos is positive here, only sine is positive here. Tan is positive in 3 and 1. So 2 and 4. So they could end in 2 and 4. Okay, we good so far? Let's take a look at E. E is a little bit more complex here. So it says cos is negative, and at the same time, cosecant is positive. Oh, cosecant. Oh, so we have to remember what cosecant is. Cosecant is 1 over what? What's cosecant 1 over? Shout it out. Sine. No, remember the co-functions? So if we've got sine, it's matched with cosecant. If we've got cosine, it's matched with secant. If we've got tangent, it's matched with cotangent. So one is a co and one is a no co. That's how you remember. So cosecant is 1 over sine. Okay. So this is positive. So that means really that sine is positive. Okay. This is the same as sine being positive. Okay. You don't even have to. You can just convert that, because wherever sine is positive, the cosecant will also be positive. So cos is negative, sine is positive. Okay, so cos is negative, sine is positive. Well, that looks like right here. Okay, does that look? Oh, no, cos is positive here. Cos is negative. Okay, so it's not 4. Cos has to be negative. Well, cos is negative in 2 and 3. That's where cos is negative. And where sine is positive is in quadrant 2 only. So there you go. It must end in quadrant 2, and that's why you have this quadrant 2 there. Okay? Okay, let's move on. That's enough for 3. Someone asked about 8 as well here. So let's take a look at 8, and we'll do 8 and 9, and then it should be good for today for covering some of this homework. So question number 8, the point P of theta, and that is 3/5 and y, the y is unknown, it lies on the terminal arm of an angle theta in standard position on the unit circle, quadrant 4. Okay, it's very important. So it's in standard position on the unit circle, and it's in quadrant 4. So I would encourage, and I'm a big sketcher, so you should sketch things. It's good to have a visual of the big picture. You can put your knowns on there. You can kind of get an idea of what you're looking for. It helps you be efficient in how you find the answers to these questions. So standard position, okay, vertex is here, great, start over here. And then it's in the 4th quadrant. So P of theta is in the 4th quadrant. Notice that the first coordinate here, the x coordinate of this point is 3/5. 3/5. Okay, so 1 is over here, 3/5 is definitely going to be, inside of 1. That's great. It's on the unit circle. So if this is the unit circle down here, it's going to be right here. Okay, quadrant 4, and it's on the unit circle. So what else we know about the unit circle is we know that x squared plus y squared equals what? What's the equation for the unit circle? Equals? Who remembers? 1. That's correct. Yes, x squared plus y squared equals 1. So that means that all of the xy pairs, the values for the xy pairs that lie on the unit circle, anywhere on the unit circle, must satisfy this equation right here. So what this means is that if we have 3/5 for x, I can just plug that into my equation. And a says I need to determine y. That's the first thing I'm doing. So I'm going to let y just stay as y, and that's what I'm going to solve. So I've got 3/5, and I've got that squared. So I'm going to bring the 3/5 squared over to the other side. I've got y squared equals 1 minus, now 3 squared is 9, and 5 squared is 25. All right. So now I have y squared equals, I'm going to have to subtract these two values. I need a common denominator. So I'm going to make 1. I'm going to make that 25 over 25. Everybody see that? So 25 minus 9 is 16. So 16 over 25 is the value on the right side. And of course, that's not what y equals. That's what y squared equals. So I'm going to take the square root of both sides to isolate y by itself. And of course, these are perfect squares, so that's going to be 4 over 5. Awesome. Okay, so my point, the point that's associated with this angle, whatever that angle is, we don't know what that is yet, but the point is 3/5, comma 4/5. Okay, you good with that? That's A. Use the equation of the unit circle. What's the value of tan? Okay, well, we know that because this is the unit circle, I know that this is cos of theta right here. And I know that this is sine of theta right here. That's what those values are. Okay? And so if I want to know what tan is, remember what tan is equal to? Tan of theta is equal to what divided by what? Who remembers? Close. Sine over cos. Yeah, sine over cos. So cos over sine would be the cotangent is the flip. It's sine over cos. Okay. Okay. So you guys are, I don't know if it's early in the morning or what, but you guys are pretty hesitant on a few things here. This equation of a unit circle, got to know that. That'll be the tip of your tongue. Okay. This cosine is the first one, sine is the second one. Got to know that. Tip of your tongue. Tangent, memorize this. Okay. And because you have notes, and because you might have cue cards for evaluations or whatever it is, your study notes, you still need to memorize, okay? Because you don't want to be looking up every little thing like this. Your homework's going to take you 3 hours, okay? So put some time into it. Try and get familiar with this. Memorize some of these important things. All right, okay. So sine over cos. So that means that tan of theta here is 4/5 over 3/5, or 4 over 5 times 5 over 3. The 5's cancel out. I'm left with 4 over 3. So tan of theta, this is B, tan of theta is 4 over 3. And finally, we'll do C here. What is the value of cosecant theta? Cosecant is 1 over, let's see, we talked about this earlier today. 1 over sine. Good, that was quicker. That's good. These ones you got to know too. Okay? Sine, cosecant, cosine, secant, tangent, cotangent. Those are the reciprocal identities. All right. So C, 1 over sine. Okay, sine is 4/5. So 1 over 4/5. Okay, the cosecant theta is actually 5 over 4. Okay. Any questions about 8? For those of you that did that question, did I get the right answers there? Do those match up? So one last thing before you move on here is we got to be careful with our signs, being that this is quadrant 4. Okay, the y or the sign is negative. So I got to go back here, make some adjustments. Y, negative 4 over 5. Okay, so A, is negative 4 over 5 because, yes, this is in quadrant 4. B, okay, this is negative 4 over 5 here, so this has got to be negative 4 over 3. And cosecant, okay, well, the sine, remember the sine is the second, so this is actually a negative, so cosecant is going to be negative as well. Okay? So that one final thing, you don't want to forget your signs, okay? We were so focused on the values there that we forgot to integrate this, the whole point of quadrant 4. Okay? So, negatives all around. All right, question number 9. Question number 9, determine the exact value of each expression. Okay, so this is where, and you can see on the right, I've done a little bit of work of this already, but what we want to do is we simply want to replace values from the unit circle for these trig functions, and we just want to evaluate. So we need to look at the unit circle. So example for A, okay, so for A, I don't know if I have A here, I don't think so. For A, cos of 60. So if you go back to a unit circle, where do I have my nearest unit circle? Here we go. Cos of 60 we said was positive 1/2. Okay, so cos of 60 is actually 1/2. Okay, this can be straight replaced with 1/2. The sine of 30, go back to a unit circle, here's 30. The sine is also 1/2. Okay, 1/2. So we have 1/2 plus 1/2. The exact value is 1. Okay. Let's do C. C looks a little bit complicated, maybe. So a C here, cos of 5 pi over 3. So again, your unit circle is going to be pretty important. Again, you should have a unit circle in your notes there that you should refer to. 5 pi over 3. Well, I've got 1 pi over 3 here. There's 2 pi over 3. This is, where's 4 pi over 3? 1 pi over 3, 2 pi, 3 pi over 3 is here. That's pi, 3 pi over 3. Here's 4 pi over 3. So where's 5 pi over 3? Right here. Okay. So 5 pi over 3, you should be able to find that on your unit circle. And of course, I'm looking for the cos, again, 5 pi over 3. Okay. So 5 pi over 3, the cos is 1/2. Look at that, it's a pretty common value here. So 1/2. Now this is times, so I need to multiply. See, multiply. Secant of 5 pi over 3, secant. Okay. So when we're looking at secant, right, remember that secant theta is 1 over cos theta. Okay. So I need to find cos theta because there's no secant or cosecant or cotangent on the unit circle. You instead need to find the cosine and then flip it. Okay. So let's find the cosine of 5 pi over 3. Cosine is negative root 3 over 2. Negative root 3 over 2. So I'm going to flip that. Easy, flip it. Oops. Times negative 2 over root 3. So that's what we get. We have to flip negative root 3 over 2. So here you'll notice that the 2's will cancel out. We're multiplying here. So you have a 2 as a factor on the top, 2 as a factor on the bottom. Those cancel out. You have negative 1 over root 3 or negative root 3 over 3 when we rationalize the denominator. So right now I think either one is okay. You're going to see that this is the true simplified version, but I think they're okay still here with these values. All right. And then f, I believe this is what I have f here on the side. So cotan of 5 pi over 6. Cotan, remember, is cos theta over sine theta. So we'll go to 5 pi over 6, and we'll do that cos over sine. And here you go, down here, those values, something got erased here. Cos of 5 pi over 6, where's 5 pi over 6? Should be right here. So cos is negative root 3 over 2. There you go. And do that division. You end up having negative root 3 squared is positive 3 for f. Okay, so there's the solutions for A, C, and F for you. Any other questions? Any other questions about 3, 8, or 9 here from 4.3? Yep.
In the back of the book.
Okay, good point. 9C here. I think we inadvertently wrote down the sign here. So 5, let's go back to our unit circle. 5 pi over 3 here. Yeah, I think I circled root 3 over 2 for some reason. But the secant is 1 over cos, which is 1 over 1/2. So yes, this needs to be changed to 1 over 1/2 is negative 2 over 1. There we go. Get the right value there. I think I said cos, but I just wrote down the sign, I guess. So that does change this answer here for 9C. Okay, if you spotted that while you were working, then that's good for you. So 1 is positive and 1 is negative, right? So we have cos and, oh, actually, no, they're both the same value. So I guess they're both positive now. So that's not a negative 1/2. So that's positive 1/2 times positive 2, and that is an answer of 1 there for 9C. Okay, good. Any other questions or anything else you see that you need to ask about? All right.